On speaking, please mute, and thank you for being on time. Please note that this gathering is going to be recorded and the video will be made available to watch later. I'm Dave Hunt. I'm an automation engineer working in the Firefox Product Integrity Test Engineering team. And I started these gatherings as a way to keep up with the latest projects and practices. The format's a monthly gathering with a guest to talk about a project I'm working on. This is basically something that I enjoy attending, and there was nothing of this kind at the time, so I started it so I could attend, essentially. You can join us on the Integrity channel on Mozilla's IRC network or Automationeers on our Slack, and these can be used for sharing any resources. I'll try to cross-post anything, so if it goes in IRC, I'll post it into Slack. And that can also be used for discussions and questions. I'll check that when we get to the time for questions, if anybody is able to type but unable or wanting to speak. I try to schedule these every month. The times and dates vary depending on the guest. Look out for an invitation for November's event, where we'll have Chris Harches and Matt Brandt, and they're going to be sharing their adventures in Android device testing. If you're interested in being a guest or have feedback or suggestions for guests, please drop me an email. We may not use up the full hour, and there should be time for questions towards the end. And if you've just joined us, I'd like to remind you to please mute unless you're intending to speak. And note once more that this event is being recorded. So all that's left is for me to introduce our guest, and rather excitingly, our first external guest for these gatherings. Peter Hedenskog works at Wikimedia Foundation on the performance team. He's based in Stockholm in Sweden. Peter is passionate about open source. He's opened a number of performance-related bugs against Firefox, so thank you, Peter. And enjoys listening to soul music. He goes by Soul is Love on Twitter. You can also often find him talking about performance on Mozilla's IRC network as P. Hedenskog. And so thank you for being our guest, Peter. And considering it's now past 10 p.m. For you, I'll hand it over.
Thank you, Dave. Today we're going to talk about performance at Wikipedia, but actually we are going to talk about measuring web performance at Wikipedia using synthetic testing tools, and that's my area where I work. So I think the presentation will take maybe 25-30 minutes, and then I will share a couple of graphs of tools we use and what it looks like, and then I will share the presentation, then a couple of links, and then we can have questions if you have any. So let's go ahead. My name is Peter. I work in the performance team. I've been working there for 3 years, and I love open source, and I'm one of the creators of an open source web performance tool called sitecp.io. In the performance team, we are 5 members. Everything we do is open source. We have our tracking open. We use Fabricator. So if you want, you can go and check out what we do. We have a really big area of different things we do within the team. And my take on it is I work on synthetic testing. And I will talk about more what that is later. Wikipedia. So I kind of like this look because the logo looks a little bit like the Death Star, you know, on Star Wars. First, since you are engineers, this is what a request looks like at Wikipedia. So we are using Nginx, Varnish, and we store the data in MariaDB. But this is just for you to get like the big picture of how everything is set up. We use our own MediaWiki. That's the wiki that drives Wikipedia in PHP. We have a lot of page views. So it's important for us to know that we are performing well and that we don't have any performance regressions. Or if we have any performance regressions, we want to know about it. You can check out our analytics tool that is open also, so you can see what kind of traffic we have on different browsers and different wikis. Wikipedia has a performance problem, and more of a performance problem of measuring the performance, because all wikis on different countries are different, because you can each wiki have different JavaScripts. You can decide what kind of extensions you want to run on each wiki. All pages are also different. You can run different extensions on each page. And all users are also different, because you can have different extensions or JavaScripts running on your own as your own user. So everyone is having their own performance experience on Wikipedia, and measuring that can be hard. But first, back to the roots. What is web performance? So we want to know how our users is doing. And there was a smart guy called Steve Souders a long time ago that did a study where he saw that 80 to 90% of a user's time is spent on the front end and not on the back end. So in this graph, you can see if we are measuring the Barack Obama page for the English Wikipedia, the user spends like 93 to 95% on the front end and 5 to 7% in the back end. And by back end, we mean time to first byte and sending the HTML, and front end is until everything has loaded on the screen. So if you look at that, web performance for us is to handle the front end, to make sure that we can measure how fast it is, and to find out if something has changed and if we have a regression. Another thing in web performance is RUM, real user measurements. So what we do with from real users, we use the navigation timing API from different browsers, from Firefox, for example. That's an API that is standardized between browsers, and we sample the data. So for X amount of users, we send back the data to our servers, and we collect it, and we can graph it. So in that way, we can actually collect real metrics, real performance metrics from users, but it's quite browser-centric, because it's, you have when DOM content is loaded, how long time it takes for the first request, and so on. So we have the RUM data from real users, and then we have synthetic testing. Synthetic testing is setting up a computer somewhere in the world and try to drive it and have it as isolated as possible, so no one can touch it. And you start your browser automatically, you load a web page, and you try to measure how fast it is loading. The goal for us within the performance team is to find performance regressions. Because, as I said earlier, we have a lot of different wikis, we have a lot of users, we have a lot of people that are pushing code and do changes, and sometimes it's hard to know if you are doing a regression or not. So we want to have a way for us to know if we have a performance regression, because we don't want to be slower for users, right? So to be able to find regressions, there's one thing that we want, and that is to have stable metrics. Because when we are measuring the performance of Wikipedia, if we have stable metrics, if we have a way of actually measuring the same page over and over, and the metrics are stable, then we know that if we ever get a regression, because I do a bad push of some code I wrote, we will see it, because we have stable metrics, and a small change of those metrics is a regression. But be able to get stable metrics, there's a couple of things we need. So first off, we need a stable server. At the moment, we are pushing our synthetic testing servers on AWS. We have worked for a while to test out different setups. We tested Google Cloud, DigitalOcean. bare metal, and AWS. And what's interesting is that having your browser running on a server is fine, but on different cloud providers, you get different stability over time. So for some providers, the metrics can go up and down depending on what else are running on that server, on what kind of isolation they have. So we need to find a stable server. And at the moment, we use AWS for that. We need to have stable connectivity because when we push Wikipedia to the browser, we want to make sure that it is the same connectivity all over or when we run our tests. Because if we have the same connectivity, hopefully we can measure the time spent, the time the browser uses to actually render the page. And we also need to have a stable page because different pages are actually harder or not so hard to measure. It depends on how much JavaScript and how things are loaded within the page and so on. We need to have a stable browser because different browsers can give different stability on metrics. And also what we have found out that different browsers need larger instances on the servers that we use to give us more stable metrics. And the last thing that we need is to have a stable performance tool. We need to have a tool that we can trust, that we know works well, and that we can have control over. So we have the synthetic testing, and we have the RUM. So what's the difference? With the RUM, we collect data from real users. We do that all the time, but we get metrics from the browser. The navigation timing API for Chrome, we can use the first paint and so on. For our synthetic testing, our browsers that we run ourselves in the cloud, where we try to have it isolated environment, we can add some extra features. For all the runs we do, we record a video of the screen to be able to analyze the video with an open source tool called Visual Metrics, where we can get actual first visual change. We can get things like speed index, last visual change, when the largest image on the screen is painted, and so on. So it is like this synthetic testing and RUM is the way we do it because they are good at different things. RUM because we get it from real users, right? Synthetic testing because we can get some more out of the actual what's happened on the screen instead of just getting the hard technical metrics that you get from the browser. I wrote a blog post on our performance blog on our team blog about the actual metrics that we collect that you can look at if you are interested. So we use a couple of different performance tools. First, we ship we ship some JavaScript code to each and every user that when they are within the sampler, they do a callback to our servers and tell us the data that we can collect, like mostly the navigation timing data. We have a small extension to MediaWiki that the team has written, and that is open source. Everything we do is open source. Right now, we take the data from the browser, we send it back to us. It later ends up in Graphite, and then we graph it in Grafana. What's cool about these metrics is that every user has different connectivity, they have different CPUs, they are running from different areas around the world, but the metrics are actually following following the same pattern each and every week. So we can see on Sundays at different hours, for example, we can compare with 1 week later to see that something has changed because usually the metrics are the same if you go back exactly almost like 1 week back in time. So the pattern for a week is almost the same for our RAM metrics. We use web page test to do one part of our synthetic testing. Web page test drives Firefox and Chrome for us on Linux. We have a server and we have an agent. And when we need some extra testing, like for example, when we opened up a new POP in Asia, we deployed a couple of other agents, web page test agents, one in Japan and one in India, to be able to see what kind of metrics we would get when the new POP was out. With web page test, if you haven't tried it, you can use the online version, webpagetest.org, where you can run Firefox and get a video of the screen, and the video is analyzed. And then we use browser time. It's one of the tools, SiteSpeed.io tools, together with web page replay. And web page replay is a replay proxy. And we use that because we want to measure the performance of the front-end code, the JavaScript, the CSS, and how long time it takes to render the page. Web page replay, if you haven't used it, is a tool that the Chrome team uses internally to test Chrome. It has a record mode, so first you record a web page, and then you replay the web page. When you do it like that, all the different things that can happen on the server is moved away. We are running the tests, the browser and proxy on the same server, so we have no latency. We set the latency on the network card, and we do that to be able to have some kind of more realistic view of what it looks like for a user. But with using a replay proxy, we get away with different time to first byte, so we have always the same time to first byte. So the only thing that will differ is how long time it takes for the browser to actually render and parse JavaScript and so on. So we use 3 tools today to collect the metrics that we need. But how do we do the testing? Yeah, so as I said before, we use Firefox and Chrome on Linux. We used to run on Windows, but it has never worked so good for us. I don't know, I think you use web page test for your tests on Windows, but at least for us, it hasn't worked out so good. When we do our testing, we do a couple of runs, because usually browsers will have some kind of difference in metrics. So we use X amount of runs, and then we take the median run and use that. And that way we have quite stable metrics. For when we test our mobile site, that isn't so complicated. We can use 5 runs. When we use NWiki, the English Wikipedia, we use 11 runs at the moment to be able to get more stable metrics. We usually test the most pages or most wikis, or a couple of wikis, I should say, on different latencies. We set on a latency to make sure that it's easier to find regressions, because if we are not tested with any latency, it's hard to actually find regressions. We have a lot of pages. We have a lot of pages. We have a lot of wikis, but we actually only test 3 pages per wiki with our synthetic testing. And we do that because we want to find a pattern on so we actually test 3 pages because it's a lot of work to test many pages. And if we test 3 pages and we see a pattern of a regression in all 3 pages, we are pretty sure that it will have a regression that will also be caused, that real users also will see. It has worked pretty good for us. But if we only test 3 pages and someone changes one of the pages, we can see a regression on one page. Then we know that's content that are depending on just that page. But if you see a regression on 3 pages, it is probably something, a code change that someone has done that we pushed. We run our test on AWS. We use C5 Large for Chrome and extra large instance for Firefox, and that's at the moment it seems like Firefox needs a larger version, but actually with Chrome 70 we are getting more unstable metrics, so we will probably move that also to a larger instance. But you don't want to have like a too large instance, because you don't. It's kind of a hard game, because if you have a too slow instance, the variation in metrics will be really high. If you have a too fast instance, the JavaScript will run really fast, and it's really hard to find a regression. We focus on two metrics mostly on our synthetic testing. First, visual change, and that is when something is actually changed on the screen. And that is good for Wikipedia, because that is almost in every case that we have seen, at least, is when you see the real text content on the screen. And then we use speed index. That's a way of showing when the content is ready within the viewport. We focus on first visual change because our first visual change on Wikipedia is really stable. And that's good, because when we run our campaigns where we ask people to donate more money, our first visual change is always, or should be, the same, because that little change doesn't affect our first visual change, but it will affect speed index. So we usually focus on first visual change because that's a good metric to focus on, because there's a lot of things that happen after that will give us some instability in metrics, but I will show you that later. We use Grafana for alerting. So we have set up alerts in Grafana where we alert on the pages per wiki. That's a way of automating that. If we have a regression that is higher than X amount of percentage, we will get an alert, so we can act on it and go through and see what has happened, and trying to understand if it's a code change, if it's a change in the browser, or if it's something in the environment or whatever. And then we also have one more thing, and that's Chrome owned at the moment. We also look at the CPU time spent. For Chrome, we parse the Chrome tracelog, where we get things like time spent in rendering, time spent in parsing JavaScript, and so on. And that's if you run in a controlled environment, that's kind of cool, because these kind of metrics are quite small, so you can find regressions quite easy. So stable metrics. I don't know if you see the screen, it's really small, so I made it bigger. Getting stable metrics is surprisingly hard, I would say, at least for Wikipedia. We spend a lot of time to make sure that the metrics are stable, but everything is moving. Our pages are changing, the browser is changing, the environment where we run our browsers is changing. So it's kind of hard to get stable metrics. This is what it looks like with the RAM data that we have. This is actually the first paint for Chrome. You can see that it's we collected from all over the world right now with I think this graph, yeah. And you can see it goes up and down. We compare it our 75% with 1 week earlier or 2 weeks earlier to try to be able to see if something has changed over time. But you see it goes up and down, and it's hard to actually add an alert that if you're above a specific threshold, we will fire an alert. But if you look at the graph, you will probably see a regression here. We started to push web page test with Chrome and Firefox. Using web page test, running on a server, accessing Wikipedia, the English Wikipedia in this case, testing Barack Obama page, we can see that for first visual change, that normally should be the most stable metric we have. We still have a lot of variation. In this case, we have a 50% variation. So setting up an alert for us to actually look at something, we need to have a quite a high. We will not find so small regressions, because we have a lot of variation within the tool, or within the setup, I would say. That is running on desktop, running on our mobile site, and using Chrome in emulator mobile mode. We can come down to 16% in this case. That's good. We can at least find a regression that is something like that. Oh, sorry. When we run our tests, there are two different things when we talk about stability. If you run on a server and you run the tests, you start a browser, you record a video, and then you do it one more time, one more time, one more time. You want to have a stability within the metrics between all the different runs. So the first thing when you try out a new server, you will try to run it. You will run X amount of runs, and you will see that you get the same metrics between all the runs, or within some kind of limit. But then you deploy it, and then you run it over and over again, once an hour for a couple of days. And then you look at the metrics. Hopefully you test a couple of pages, and you know that most of the pages are stable, so there are not so much change on the content. And then you want to make sure that on that server, the metric is stable over time, because you need to first have the metric stable between runs, and then you need to have it stable over time. And using the proxy, WebPage Replay in our case, where we try to remove the latency and the time, like the server timings. Oh, sorry. We can, in this case, with Chrome. Oh, this is actually Firefox, so that's good. We can find a regression of 7%. What we look at here is a graph in Grafana, where we graph the first visual change. The red line is it's something like a red line, right? Last visual change. So the yellow in between is where we actually output things on the screen on Wikipedia. So you can see things are started something in almost 1.5 seconds, and then it takes 300 milliseconds, and then it's ready. But testing with a performance proxy, we can find regressions that are maybe 7%, maybe lower, depending on what kind of page we are testing. And when we move to testing our mobile site, you can see here that the first visual change is over time is really low. We have a change of 3% for a couple of pages, and we also have one page that are actually really stable. And that's good, because then when someone, probably me, push a change that breaks things, we will see a really, really small regression. So I have an example of a regression that we have found. When we do deploy a new version of Chrome and Firefox, we use Grafana, and Grafana has support for annotations. So you see the blue lines that are vertical are when we do changes on the server, or we do changes on the Wikipedia. In this case, to the left, you see we had deployed Chrome 69, and I had the feeling that Chrome 69 changed the metrics, so I redeployed Chrome 68, and you can see the first visual change went down, and then I redeployed Chrome 69 in our environment, and the metrics went up. So when we usually do that, and I always make a mark and I check it, and I can see that a new version of the browser changes our metrics. So then I usually create an upstream issue in Chrome. I haven't done upstream issue yet for Firefox, because we had some problem in the past with getting stable metrics. We are soon there for Firefox. But then we usually do our push as fast as when Firefox releases a new version. When you release a new version, we push it the next day. When Chrome releases a new version, we push it the next day. but then the actual users, it will take some time before they get that version. So this is what the first paint for Chrome on mobile looks like over the same time when the users started to get the new Chrome version. So this is the 75% again. And you can see it getting higher over time. So it's a little bit regression. And when we also look at the metrics of what our Chrome mobile users are using for version, we can see that over time, the exact same time as our first paint went up, users moved from Chrome 68 to 69. If you have seen this regression without our synthetic tool that we used first, when we run our Chrome in an isolated environment, and we saw that it will create regression, we would have thought that, oh, something slipped through our testing and we released something that slowly made our metrics went up. But since we now could use both the synthetic testing and the RAM data, we can verify that the regression is because of something in Chrome. So I filed the task, and it took some time to get some interest in it. But since we saw it both on our synthetic testing using our video when we record the data or record the screen and our first paint, we got some people to look at it. But then, yeah, I don't know if you see Googlers, I believe this bug plus details in the issue. And there's a link there, and when we click at the link, oh, permission denied. So it's something secret in Chrome that has happened that we will not know. So that's a little bit annoying. I know that you will not do that at Mozilla, right? If you do some change that will reflect first paint or first visual change, I hope you will be open with it. So, okay. I worked with setting up web test and browse time web replay for a couple of years and trying to make it as good as possible. So I want to talk about my top 5 learnings, if someone else wants to do the same. The first thing is that all pages and servers are different. So you really, when you collect the metrics, when you collect things like metrics from the video, metrics from the navigation timing API, even if you use it in an isolated environment, you need to collect the deviation between runs, because you collect it and then you can look what it will look like over time. If you change server, if you deploy a new version of the tool, if something on the page has changed. Because in our case, that has changed over time, and you need to make sure that to be able to have stable metrics, it's good to have a low deviation. So it's really good to also graph that and keep track of it for all the metrics that you collect. I didn't do that in the beginning, I missed that. So it's what's more of a guessing game, but when we have that up and running that we have now for all the things that we do, it's really good. Yeah, and in our case, it looks like this. If you use Chrome on mobile, we have a small deviation between runs. Another thing is that auto-deploying performance test tool is evil. So we are working on that. We don't have it up and running right now, but at the moment we are auto-deploying web page tests. So when there's a new change at GitHub, we auto-deploy it, and when Firefox is released, we are auto-deploying Firefox, auto-updating it. So we don't have control of it. And this kind of sucks because it happens now and then that something has changed and something is broken. So I really think it's important to make sure that you don't automatically deploy new versions. You need to do it by hand. It's a lot of extra work, but to be in control, you need to do that. The third thing is that one video is more than 1,000 navigation timing metrics. So I really like videos, videos of loading a web page, because it will say more things of what it actually looks like for a user instead of just collecting some metrics that is like hard to relate to. So videos is really good, and it's good to be able to relate to and show to other developers and talk about and how can we do this better. worse. The fourth thing is that Docker is really great for web performance testing because it simplifies things. First of all, for us, we have a controlled environment that is quite simple. We can do controlled deploys, and we are versioning the browser, so we are having different tags on our containers depending on which browser version we are using. So it's super easy to do a rollback. At the moment, we run our tests on a couple of servers, and when there's a new version, I just log into the server and change the version tag and pull down a new container and try it out. And at the same time, I just make a mark in Grafana so I know what I have done, so I can keep track of it. We don't have anything fancy right now with deployment, so we do it by hand, but it works quite okay because as long as you have a versioning of what you do and you can roll back and you can do a control deploy, it's really good because during the years, a lot has changed. Like when you do an update on the browser or the tool that you are using or the server, the metrics will change, and you need to take control of that so you know when changes are happening. Number 5 is that performance proxies are really cool for measuring front-end performance that we do with web page replay. When you do that, you need to make sure that the proxy is returning the same thing as what it looks like for real users. When we tried out Mahi, and there's a patch there to make it work for HTTP2 by Benedict Walters. We tested out web page replay, and there are a couple of others that you can try out. I think you are using that 100 today, right? But it's good, but you also need to, for us, we have the proxies that we use, but we also try it without proxy. So we also test with a real from our real servers. So we get the best of both worlds. Yeah, the last thing is getting stable metrics is a moving target. It's a lot of work to make sure that the metrics are stable. And because, for example, if you run on AWS, the metrics can, depending on what else run on the same instance. So we have, for example, if I have C5 large, we run our things, we run it standalone. But if something else has happening in the area where they have the physical servers, we have seen that metrics can go up and down. So a couple of times I've deployed a couple of different instances, and then I take the instance with the most stable metrics and tear down the other metrics. We don't have anything set up right now for doing it automatically, but that is probably needed if I have a good way of doing it. So the next step for us, I think we have a quite good setup at the moment, but we're missing a couple of things. So we test on our live production Wikipedia. We want to run performance test on commit to be able to know before we push things to production that we have a regression. We don't have that today. We want to run tests on real mobile phones. We don't do that. We only run on desktop and where we run Chrome on mobile, emulated mobile. So we do not do real tests on mobile at the moment. And we have a long list in Fabricator of things we want to do. So that was the presentation. And you can hit me on IRC or email me or find me on Twitter if there's something that you want to ask. And you can ask me here too. I want to show you a couple of things on Grafana, just our dashboards. Because I kind of like it because it's open and it's so super simple for everyone to look at. Yeah, so this is Firefox, where we run it with web page replay. Most of our dashboards looks like this. We have the metrics. Here is where we actually do the change, the first feature change on the screen. We test a couple of pages, you see, like the Sweden page, the Facebook page, the Barack Obama page. And we also graph the variation. the deviation within the metric that we are measuring, so we can find URLs or pages that have a lot of deviation, and then maybe we can stop testing that and change to another page, because we want to have stable metrics, so it's easier to find progressions, right? The lines, if you haven't used it, is the annotations. So for example, when I do a new deploy where I upgrade Firefox, I make an annotation. We also have our deploys when we deploy things to Wikipedia. Okay, so it's super slow now. I don't know, but you see the a couple of lines that yeah, it isn't doing so good at the moment. But we can see when we do actual deploys on our production, so we can best case see that something that we deployed also have an impact. And if I see that, I need to go back to our changelog and go through everything that has changed in the latest push. We have a couple of different dashboards. I can show you. So we have speed index, a couple of other metrics that to collect, and things like largest images when the logo is displayed. We're only collecting it. We are not acting on that at the moment. We have a lower level too, where we can go on individual page. Yeah, so we graph the data. We have the latest screenshot, so it's like easy to see if something really bad is happening. Yeah, and for Chrome, we have the extra thing where we can keep track of time spent in rendering, scripting, and so on. Yeah, and then for we also have navigation timing data. So our Grafana instance is open, so you can also go there. You can look at our performance data by browser. Only thing right now, for example, with Firefox, is that we have so low traffic, and since we sample the data, we cannot compare the metrics that we are collecting for Firefox or other browsers with the browsers where we get most traffic at the moment. We have a way of oversampling, but we haven't done that by browser at the moment. We have done that for different areas in the world. But it's possible that you can find some interesting stuff here if you look at it. Yeah, I think that was all I had.
That's excellent. Thank you, Peter. So I have one question to start us off. Would you be able to share your slides?
Yes.
Thank you.
So, how do I get this now? So it works.
If you want to drop any details in an email to me, I can make sure I distribute it with anybody that was invited to the.
I'll do that. So I will send you the presentation and then all the links to our dashboards and our setups. Because what's kind of good is that we have worked a lot of documentation into how we set up things. So when we do it the next time, we probably know how it works. Just following the documentation. Yeah. So I will send you the link.
Thank you. So I do have some more questions, but I want to give a chance to anybody else that's got their own questions for you.
I can jump in. Hi, Raoul here. Peter and I talked a bit in a while about performance. One question I had, did you ever try to validate the metrics you're shooting for against any engagement metrics or other metrics that Wikipedia is tracking?
Yeah, so Gilles in our team is working at actually looking at that at the moment with our, but that's only for RAM data. So like, what is there any metric that we collect from the navigation timing API that we can correlate to a happy user or a user that feels that Wikipedia is fast. So it's a lot of work, and he's been doing that for a while, but there will be some presentation when, when he got some metrics. It could be that there will be no correlation at all. It could be that there's some correlation, let's see. But Gilles is working on that, so that's really interesting. And you should also, I will also send you his article about MEDDIC performance numbers. I don't know if you have read it. He has gone through all the, not all, but a lot of different studies in the past, all the things that most people are talking about, like the 100 milliseconds, 1 millisecond, 1 second and 10 seconds, and try to find out if there are any real data behind that, or if it's like just MEDDIC numbers. So I will send that post too, because that's really interesting, I think, because there's a lot of rumors or I would say false data going around. So you should read that when you have time.
Cool, thanks. It's awesome.
Peter, I know that Chrome has the timeline. I think it's the DevTools timeline, and then they also have, and I think we also have, or should have at least, the TCP dump. Is it that the TCP dump for networking or page load, HTTP request issues is more of a hammer or suggestions? Find the timeline is especially helpful to correlate to the metrics you see, or do you have to go into the internals like TCP dump and compare that to Chrome's timeline, or?
No, so we don't use, so what we use with Chrome, the extra features we have is that we have the Chrome internal trace log that's easy to use. So there you get, on a tracing level, you can get each and every event, what the browser is doing. So, and then we categorize it like the same way that Lighthouse and different tools are doing it. In that way, we can, on a high level, we can see that something has changed, but then we can use the trace log when we file upstream issues. It's more of, I have never gone down to like a deep level to find out, yeah, I can see that different events are firing more often, but it's more on a browser level thing that's so far, yeah.
Yeah, it's going to be a lot more specific or a lot more pertinent to us from our vantage point.
I had another question. So on regressions, what are the typical things that you see that improve Wikipedia or regress it? Like, what are the typical problems that people are, or problems or improvements that people make that change the metrics?
So on our side, what's kind of, so we load a lot of JavaScript, but we only output like super simple articles. So there's kind of a mismatch there, how Wikipedia is built from the beginning, like over time. And we have a kind of a system to make sure that we deliver the right assets for each and every page. And since every page is like really, really different, it's in the old days when we find the regressions, I need to go back. So from the beginning, we were only using navigation timing data. So to be able to find the regression, we need to have a really, really high regression, because we need to impact most of our users, right? But with the synthetic testing, we can impact a much smaller audience. But since we are doing synthetic testing on like a low low parts, because we are only doing a couple of different latencies. We have only a couple of pages, so we are missing a lot too. But for regressions, I would say since we get everything up and running, we have mostly found regressions in Chrome instead of Wikipedia, actually. Yeah. So, for example, in a couple of versions of Chrome, they changed the native way of outputting the video player and the audio player. And that caused the regression first visual change for us on the pages where we actually output the video or audio controls. So far we haven't had a good example with like a bad deploy on our side, but we feel that we have the tools to find it at least.
So it sounds like most of your issues are network bound, but JavaScript bound. Or...
Yeah. So yeah. Okay. You assume, yeah. Of course. Yeah. So it's people have worked really hard on the backend side, our PHP stack for years and years and years, and our setup with Varnish and Nginx is working good. So it's more of JavaScript, yeah, because you can, as a user, you can set up a lot of things. You can do a lot of things on each wiki that you can make things burn.
Awesome, thanks.
Peter, I don't know if you use Optimizely. Are all of your libraries open source packages?
Yes.
Okay. So in the performance conferences, they always talk about, well, especially at the last summer's Perf Matters conference, they talked about, oh man, just lost my train of thought. Sorry, go to someone else. I'll think of it. I had a long thing I was going to spiel about. Oh, I know what it is. Head of line blocking and Optimizely or similar JavaScript third-party, A/B testing frameworks. I know you probably don't see that at Wikipedia or have that set up, but in your experience and with site speed and browser time, etc., I wonder if I'm running into that with some of our sites that Mozilla's testing, because it's all live.
Yeah, it will add, depending, and it can add like depending on your test, but like 500 milliseconds. So I mean, in your case, Stephen, I think bad since you will not be in control of what happens with all the URLs you are testing. Like I thought about it that you need to make sure that you collect a lot of extra metrics too for each and every site, like requests and sizes and so on. And still, you will
Yep.
it will be interesting to see what you can find with what changes. That is something that actually is depending on Firefox and what is actually changed on different sites. So yeah, it's kind of a bad way to go to use Optimizely. That is like right now.
Hey, Peter. Good to see you again, actually. My question is, have you guys considered re-architecting how you guys are working using, say, service workers or like that in order to improve site performance? I know quite a few. I'm biased here, obviously, but I know quite a few major websites are actually considering leveraging service workers in order to build more native-like apps that can actually improve performance. That should allow you to, pre-cache a lot of assets, things like that. Given the nature of Wikipedia and all its content base, it might work nicely. Have you guys considered re-architecting in that way at all, or are you just...
So right now it's kind of complicated because each and every page. So we have a system called the resource loader that loads resources per page. So different pages can have different extensions and use different JavaScript and different CSS. And the resource loader makes sure that CSS that are common between different pages and JavaScript that are common between different pages are cached. But since you are it's not like you are using a normal site where you have different JavaScripts, because now you can have different JavaScripts per URL, but also you as a user can have your own scripts that are loaded per page.
Yeah, I was asking because you can because I knew about your resource loaders. You actually discussed this last year. So I was asking if you maybe perhaps leverage that inside a service worker, so it's
so it's kind of
ahead of time.
Yeah, so it's a lot of work to change what we have today, and we have tasks for like investigating how we can do it in another